Welcome back. In the in the previous video, I left over here in our quest to transform this parabola to something that looks like this one over here. I'll go back to Mathematica. Background, which happened to be, the style command for plot, gave us RGB color. And if you were like me a few months ago and you had no clue what RGB colors are, then I'm sure I might have confused you quite a bit. And I took off on a tangent, and I showed to you, well, RGB colors, RGB, they're in a sequence, and each, I need color, white. Each R and then G and then B take a specific value that is minimum at 0 and maximum at 255. And they are all integer values between 0 to 255, meaning you can't have something like, say, 244.5 or 244.3. And if you're still a bit confused about RGB colors, I actually made a brief introduction to what RGB colors are, and I covered how these numbers can be used to make orange or indigo or green, blue, white, and black. You can check those videos out in the playlists. I think the videos were called like RGB color, color code, computer color, something like that. But I assume that you understand RGBs, and in Mathematica, background takes RGB, but surprisingly these are not 255. It's like you might have seen the maximum was 1, and when everything was 1, I got white, which kind of makes sense because when everything is 255, if this was 255 and green was 255 and blue was 255, the color that I would get would be white. And again, if you're feeling a bit confused and if you don't quite know why that's the case, again, check out my videos on RGBs. That will clarify any possible confusion. In Mathematica, the 255 is represented by 1. And say for a color that is black, like my background over here, the RGB would have been 0, 0, 0. For that case, well, it's 0 as well. And when all these red, then this green component, then this blue component were 0, and I shift entered, I got black background. So that made perfect sense. In RGB, specifically in Mathematica, we are using RGB color command as over here, RGB color. And the problem that actually got me into this RGB mess was, well, how do I get pink? Because I know how to get white and black, and something in between white and black would be, say, gray, and I can make all this 0.5. Or say if I would like a very light gray, I can make this 0.9, 0.9, 0.9. Enter. That's a light gray. I can make it even lighter by going one more decimal to the right. So if I make it 0.95, 0.95, shift enter, gets even lighter. And I think that's pretty much it. I mean, I can try another digit to the right maybe, but I think it's not going to work. I tried it before and it didn't work. Yeah. So in Mathematica, the RGB component values, the red, green, and blue, can be values between, let me complete RGB color. The RGB color values can be between, so the red could be between 0, 2, 1.00. And green could be the same and blue could be the same. Now what does that mean? Well, because it's 0 to 1 to 2 decimal places, I could have a color value that's like 0. Say 2, 0.2 red, which means 2/10 of a red. I could have 0.2 green, and I can have 0.2 blue, and because these are all equally being mixed, I would get black. The result would be black. So pink. Pink is a color that's red and a bit of white. Doesn't look like there should be any blue in it. So my guess, and I'm gonna try it out in Mathematica in a moment. My guess that this pink over here, that doesn't look like pink. I'll go back to Mathematica. My guess for pink, my blue component is 0, or I can say 0.00. And my red should be, I don't know, full red. So 1. Put all my red that I have, the maximum amount of red that I can give. And green, red, doesn't make sense because red and green would give me like a red-green color. So how can I add white to this red over here? Because now if I say, oh, my computer's telling me it's 5 o'clock. Interesting. Now if I press Shift Enter, yeah. So that's a total red. And if I make my green fully red, fully green with the value of 1, and then Shift Enter, I get a green. That's full green. And if I make my blue fully blue with the 1, that gives me perfect blue. Okay. And I also know that if I add all the colors in equal amounts, I get white. So see if I would want a pink. I would need red, and obviously I would need to add white to red. And I think if I'm not mistaken, you add equal amounts of blue and green to red. So now this is red, but these guys together, the blue component and the green component, which is this one, RGB. So this 2 acts like white being added to this 1, which is fully red. Enter. Whoa. That's a salmon. Okay, that's not pink yet. Well, this is pink, but the pink I want is much lighter. So I'm guessing I should add more white. So let me increase up the values for green and blue. Now I'll Shift Enter again. Aha. Getting close, but still not there. What's wrong? Okay, I think I should add more white. So let me maybe push it up to 0.9. Ah, almost there. Okay. So it still looks like, maybe make the graph a bit larger. I'll drag it up. It still looks like this is a bit more reddish compared to this graph over here, although they are the same graphs. So I'm guessing I have to now further up the whiteness made by the green. So now it's gonna go up in 1/100ths of the value, or values go up in sort of the second digit, which is this place over here, the second decimal place, or the 100th decimal place. So let me make it maybe 5, and make this 5, and Shift Enter. Okay, that looks close, maybe a bit lighter. So let me make this 9, and 0.99 can be the highest value for the green, because if it goes above 0.99, it becomes 1, which is fully green. And you can't go above 1. Let me increase 0.95 to 9, Shift Enter. Whoa, that's a red but which is really whitened out. So I think I had it as, it was 0.98 to get this type of pink in my background. Maybe okay. I think 5 was just fine. Maybe 6, because 5 was the one I tried before. Okay, it looks just right if I Yeah, if I increase the brightness of my monitor, I think 5 was correct. So stick with 5. Perfect. So that's how I get pink. You know, if I wanted to get, I don't know, a a widened out blue, it would be the same process. You know, I would make red and green equal, and I would, you know, make blue in its full color 1, and I'd get like a really light blue. Or if I would want a really dark blue, for example, I would like to add really less white to the pure blue. Pure blue would be all red, green being 0. Now if I add a little amount of white, it should get darker. Does it? It doesn't. Because it can only get lighter. 0.5, 0.5. I think I confused you. Maybe I'll correct myself in the next video how to get the blue darker, or even if that's possible. But you get the general idea of how RGB colors work. Uh, that's the background, and I'll maybe keep this pink for the sake of consistency. I'll quickly make this 0, 0. I can also just to show that these values can go to 2 decimal places. I can just, you know, add the two decimal places, 0.95 and 0.95 for the green. And pink should be coming. Whoa, what happened? Okay, I made a mistake in the brackets. Okay, it should be a square bracket. Mathematica tells me. There we go. Okay. And this is the exact graph as the one I had on my right hand side. Uh, they both they both are parabolas, and now it looks proper because now, as this perfect square form indicates that, okay, this function was shifted 100 units to the up. And if I say made that plus 200, you know, the graph went up to 200. So yeah, everything that happens in the function is sort of directly shown in the graph right after I press Shift Enter, which is really cool because in the next videos when I compare, you know, really complicated graphs by some really wacky functions, it's really helpful to see how do these functions look like? Like what are their shapes? What type of what type of curves and what type of connections they make. Uh, so I will see you in the next video where I will make more graphs and cover more of the style commands in plot to sort of, I don't know, extend the range to bottom and add more graphs, change the color of the graph, make it maybe of a different color, and all types of things to make the graph look prettier and more nice.